Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the pH when you're dealing with dilute solutions of H2SO4, sulfuric acid. So the special thing about sulfuric acid is that the first and second proton that come off fairly readily. So the first proton is a very strong proton. So sulfuric acid is a strong acid. That first proton comes off completely, right? So, and then the second proton comes off fairly well as well. So you got to take both of those protons into account when you're trying to figure out the pH of your solution. So one of the things that makes it easier is you can treat the first proton as coming off completely because it's a strong acid, and then start with that when you're doing your ice chart. So for example, here are the two equations. So this is strong. So this is a strong reaction. So what that means is that 100% of the first proton comes completely off. So this is one directional, so it goes in one direction. And then the second proton comes off fairly well, but it's more of a equilibrium. And the Ka value for that is, so K2, that would be 0.012. Okay, 0.012. And so what we want to do is, since we know that the first proton is going to come off completely, then we could use the starting concentration of the H2SO4 as the concentration of HSO4 and the H3O plus concentration to begin with to start. So let's do that. So we're going to look at this equation here. And we're going to set up our ice chart. So the initial concentration of HSO4 minus is going to be this concentration here, 0.0100. And this is going to be, we're going to ignore water. And then the initial concentration of H3O plus is also going to be the original concentration, because the original amount completely ionizes. And so whatever you had here, you now have for these two. So we're just going to put that here, 0.0100. And this is a 0 at this point. So to start, we don't have any SO42 minus ions. So this is our initial conditions, our initial concentrations. And then we're going to go in this direction. And we're going to lose an X amount of our HSO4 minus. We're going to gain an X amount of H3O plus, and we're going to gain an X amount of SO42 minus. And so we add all this together, we get 0.0100 minus X. And again, this is plus X, and this is plus X. And then, so now we just set up our Ka. So Ka2 is equal to 0.012, which is equal to the concentration of these two. So it's going to be H3O plus multiplied by the SO4 2 minus concentration over the concentration of HSO4 minus. So we're going to put in x's for these, so that'll be x squared. So 0.012 is equal to x squared over 0.0100 minus x. 0.0100 minus x. And so now what we need to do is we need to solve for x. And in this case, since this is pretty close to the original concentration, we're not going to be able to do the x is too small approximation. It won't work. So in this case, we'll have to do the quadratic formula. So we'll have to manipulate this. So we have to multiply both sides by this, and then we'll have to get x on the side. So what we'll end up doing is solving a quadratic equation. And so what you end up getting is, if you solve both sides, you multiply both sides by this on the bottom, you end up getting 0.0100 minus x multiplied by 0.012, and that's going to be equal to x squared. And then you got to multiply this out, so you're going to have 0.012 multiplied by x minus, and then you got these two multiplied together, and then you end up with a quadratic formula. And then you're going to have to use the quadratic. You're going to have a quadratic equation here. You're going to have to use the quadratic formula to solve that problem. I'm not going to go over it here, but once you solve the answer for the with using the quadratic formula, you're going to get, let's see here, you're going to get negative 0.027, negative 0.027, or you'll also get 0.0045. So 0.0045. Let me double check. 0.0045. Yeah. So now because the quadratic formula gives these two values, you've got to choose one. Well, you can't have a negative concentration, so this can't be the answer. So that's going to be your x value. And so that's the x value for the hydronium ion concentration for your second proton. So what you're going to have to do now is take this amount here. This is the amount of hydronium ion that is added to the amount of hydronium ion you had to start with, which is 0.0100. So you add those together. So you add that plus 0.0100. Add those together, you get 0.0145. So that's your H plus concentration. And then you're going to have to take the negative log of this. And keep in mind that we only are allowed up to this place here, since our lowest number of decimal places, we are only allowed up to the 4. But when you take the negative log of this, you get 1.85. So the pH is equal to 1.85. So that's the pH of this solution of sulfuric acid. Okay, so that's the first problem. The second problem, very much like the first, except this time we're given, this is the concentration of H2SO4, and they want the SO4 2 minus concentration and the pH. Okay, so how do we do this? Okay, so I erased the board to make some more room. So basically we're going to do the same thing as we did before. Here we're going to assume that all of the first proton came off because it's strong. So whatever concentration we have of the acid to begin with, that's going to be the concentration of HSO4. We're going to start with the second equation. And this will also be the concentration of the H3O plus that we'll start with, because all of it dissociated. So all of this dissociated into HCO plus and HSO4 minus. So if we do our ice chart again, down here, so the initial concentration is 0.0075. So we have 0.0075 for our HSO4 minus. For the H3O plus, we also have that for our starting concentration, 0.00075. And then for our sulfate ion, we have 0 to start with. And then now we're going to find the change. So we're going to lose some of our acid here. And we're going to gain some more hydronium ion. So that'll be a plus X. And then we're going to gain some of our sulfate. That's also going to be a plus X. And then we add these together to get our equilibrium expression. So 0.0075 minus X. And again, this is going to be plus X. And this is going to be plus X. All right, so now we have our equilibrium expressions. Now we can set up our Ka value. So we have Ka2 is again equal to 0.12, which is going to be equal to the concentration of H3O plus multiplied by the concentration of SO4 2 minus all over the concentration of HSO4 minus. So HSO4 minus. And so we're going to plug in our equilibrium expressions to the equation, and we get 0.0, that should be a 0, there should be a 0 here. So 0.012, 0.012 is equal to X squared over 0.0075 minus X, okay? So here, once again, because this here is pretty close to this, we're not going to be able to do the X is small approximation. So again, we're going to have to do the quadratic formula. So we're going to have to solve this for the quadratic equation and then use the quadratic formula to solve. Okay, and then so what you're going to do is you're going to have to multiply both sides by the bottom. So again, we'll get 0.012 times 0.0075 minus X. And that's going to be the X squared. All right, so let me, and then we're going to have to multiply this out. Okay, so then when we multiply this out, and so when you solve it, you get this. So then you multiply this out, bring X to the other side, and you get 9 times 10 negative 5 minus 0.012X minus X squared equals 0. And now you're going to use the quadratic formula. And the quadratic formula, just to remind you, is, let me write this down. So X is going to be equal to plus or minus the square root of negative b plus or minus, oops, I have this. So negative b, let me do this again. So it's negative b plus or minus the square root of b squared minus 4ac, b squared minus 4ac, all over, I believe it's 2a. Okay, and so where the a and the b and the c are the coefficients here. So okay, and so when you solve this quadratic equation, you're going to get X is equal to 0.00386, 0.00386, and that is going to be both the this is going to be both the concentration of H3O plus and the sulfate